So we have question 10. It says the diagram below shows two small identical spheres, P and Q, on insulated stands. The charge on sphere P is -3 times 10 to the exponent of -6, and the charge on sphere Q is unknown. Now 10.1 says calculate the number of electrons in excess on sphere P, right? So in order to calculate that one, we use the formula N is equals to Q over E, right? Now the E is the constant, -1.6 times 10 to the exponent of -19 coulombs. So this is the charge on electron, right? So the charge on an electron. Then the Q here represents the charge of sphere P, right? So what is the charge of sphere P? We have -3 times 10 to the exponent of -6, and our E is -1.6 times 10 to the exponent of -19, right? Now if you punch all this in your calculator, you have 1.875 times 10 to the exponent of 13 electrons, right? So this is the number of excess electrons on sphere P. Now they say the two spheres are brought into contact and are then returned to their original positions. Each sphere now carries a charge of -1 times 10, -1 times 10 to the exponent of -6 coulombs. Now we understand that when the two spheres are brought together, they will share the electrons amongst themselves, and then they will have the same magnitude of charge after contact, after they're then separated. Now we are being told that the charge on each sphere now is -1 times 10 to the exponent of -6 coulombs after they've came into contact. So the new charge on sphere P is this, -1 times 10 to the exponent of -6, and also on sphere Q it is the same magnitude, right? So now what are we required to calculate in 10.2? They say calculate the original sphere, the original charge on sphere Q before the spheres were brought into contact. So what are we supposed to do here? Calculate the original charge, right? So as we can see here, we've been told that the charge on sphere Q is unknown, right? So this is the charge that we are looking for. Remember, this is here, if we look at it in terms of P, we know that the value that we have here, this is the Q initially and this is the Q final. But for sphere Q, we don't have the Q initially, we only have the Q final. So in order to calculate that one, we will use the formula. Remember, every time we are told that the spheres come into contact and then are separated, we know that we use the formula for the principle of conservation of charge, which goes Q nu is equals to Q1 plus Q2 over 2. But now we know the Q nu here represents the final charge of each of the spheres, which is -1 times 10 to the exponent of -6, right? Then what is our Q1? Our Q1 is -3 times 10 to the exponent of -6. So Q1 here is the charge on sphere P. Then Q2 is the charge on sphere Q. Then over 2. Then at this point we have to cross multiply here. So we have -2 times 10 to the exponent of -6 is equals to -3 times 10 to the exponent of -6 plus Q2. Now at this point we can take this and transpose it to the left hand side, and then we will end up with Q2 being equal to +1 times 10 to the exponent of -6. So if you transpose this one to this, it will add to that and give you 1 times 10 to the exponent of -6 coulombs, right? So that is the charge on sphere Q. So we say sphere Q, therefore sphere Q is equals to 1 times 10 to the exponent of -6 coulombs. Now 10.3 says where electron transferred from P to Q or from Q to P, right? So now looking at this, the charge that we have on sphere Q is 1 times 10 to the exponent of negative 6 coulomb, and we can see that it is a positive. So we know that the electrons will flow from the one that is an excess of electrons to the one that is a deficient. The answer here is from P to Q.